Yes. Yes. Now consider this and the subset V here, but this subset contains all vectors such that our vectors should be in this form. It's okay. What's the form? And the first component, second component, but third components will be and the sum of the first and second components. It's okay. X1 plus x3. So x1 arbitrary x2, but third one is sum of the first and second component. It's okay. So and show that V is a subspace. So first of all, I think and write this set, and it will be better and to see that V is a set contains x1, x2, x1 plus x2 third component. V contains and this and the vectors such that x1 and x2 real numbers. It's okay, this one. So our aim is to show that V is a subspace. What's in the first condition? V should be non-zero. Non-empty. Sorry. And this set is an empty set or not? So first one, our aim. Let's write here maybe. Let's use this one. And first condition, our aim is to see that V is empty set or not. So, and the right V contains vectors, but our vector should be in this form and such that the first component, second component, real numbers. It's okay, that's all. So, and look at this one, and this and the V, this set contains all and the vector. For example, look at this one, 1, 2, 0. 1, 2, 0 in V or not? Yes, yes, please. This vector is the element of V or not? Not V, because what is the reason? Since x1 is 1, x2 is 2, but and this one should be, there's a typo, x2. It's okay, but and the x3, x1 plus x2 is 1 plus 2, x3 is 0. 0 is not 3. It's okay. So not satisfied this condition. So it's not this one. But our aim is to see that this one is non-empty. It's okay. So, and you don't have to write any this part. It's okay. Our aim is to show that Rn here, V is a set here, but there exists at least one element here, 1, 2, 0. So, and this V and the V and the V is not Rn, R3. R space is R3 here. It's okay, R3. So this one is subset, yes, this set, subset, but should be non-empty. It's okay, non-empty. So, and for example, look at this one, 4, 5, 9. This one is in V because what is the reason? And because this one can be written in this form, 4, 5, 4 plus 5. It's okay? X1, X2, and the third one, X1 plus X2. It's okay in V. So, and the V is not empty set. It's okay? So, our aim is to get the non-empty, this one should be non-empty set, yes. And the second one, second condition, close under the addition. It's okay? Look at this one, this part. It's okay? close under the addition. So this one is okay. So, and let's check this condition. It's okay. And also it is easy way, and the 0 here or not. 0 here or not. And this one, 0 vector means 0 0 0. It's okay. And this one is in V, because what's the reason? This 0 0 plus 0, because it's okay in V. So V is not empty set. This one is, and choose and the special vector, because we know that, and the 0, if V is a subspace, 0 here. It's okay. So, and another, and the second one, uh, close under the addition, and take the two vector here, V here, is okay. For example, take x and take y. Our aim is to show that x plus y here. It's okay. Check that x plus y here or not. And assume that take the x in V. In V means, and the x satisfies this property. It's okay, this one. So x is x1, x2, x1 plus x2. It's okay, this one. And take another vector y. It's okay, y is y sub 1, y sub 2, y sub 1 plus y sub 2 in V. Take the two elements. Our aim here, and the x plus y in V or not. It's okay. Our aim is to show that this one. So let's compute the x plus y. X plus y, write x, the vector, also matrix this one, special matrix. So, and plus the second one, y sub 1, y sub 2, y sub 1 plus y sub 2. And this one is the sum of the, and the two matrix, we know, and this one. So how to get, and this one gives the matrix, and this one gives the vector, and how to get sum of the corresponding entries. So this one is x1 plus y sub 1, x2 plus y sub 2, and this one x1 plus x2 plus y sub 1 plus y sub 2. So this one is in V or not, and we know that every entry here real numbers. So we know that real numbers and addition and real numbers commutative, and change the order. And so this one is, this part can be written in this form: x1 plus y sub 1, the first one, x2 plus y sub 2. Yes, look at the third component, and the rewrite third component, we can write x1 plus y sub 1 plus, change the order, x2 plus y sub 2 can be written, because x1, x2, y sub 1, y sub 2 real numbers. It's okay, can be written. So look at under this form. First one, it is not important. First one, it is not important. Second one, not important, any real number. But the third one should be first one plus second one. Yes. So this one is in V, because V contains and the vectors such that satisfy this condition. It's okay, this one. Any question? Okay, so, and satisfy the second condition. It's okay. So, and you have to check the third one. Third one, yes. Third one, what's the third one? And the third one, take any vector in V, x, x1, x2, x1 plus x2 in V, and they take the any real number r, It's okay. Our aim is to show that scalar multiplication and close under the scalar and this one r times x in V or not. It's okay. Our aim is to show that this one. It's okay. So how to show that? And compare to this one. It's okay. R times x. So r times x, yes, right. R scalar and the x is our vector in V, x1, x2, x1 plus x2. So, and this one is scalar multiplication. We know when scalar multiplication for matrices and means take this scalar, multiply all elements by this scalar. So this one gives r x1, r x2, r x1 plus x2. And so rewrite this one. And so first one rx1, second one rx2, the third one use the distributivity and then rx1 plus rx2. So it is easy to see that in V, because what is the reason? Look at this one, first component, second component. The third one should be first component plus second one, yes. So in V, it's okay. So, and the first one, not empty set. The second one, close under the addition, and also third one. So we can say that V is a not subset only, is a subspace of R cube. It's okay. Any question? Everything is clear? Okay, no question. So let's come back. This one is this subset is a subspace. It's okay. Yes, this subset is a subspace. It's okay. This one is the same as the proof. It's okay. Yes. Now let's the next example. This one. And here take the same and the space R cube is okay here, and consider that this subset, but such that this subset consists all vectors of this form. X1 it is not important, x2 not important, but third one should be one real number, fixed near real number. So and the question and they check that this set is a subspace or not. It's okay. So this one is an empty set or not? First one, first condition. Our aim is to show that, and the V is not empty set or not. It's okay. So, and for example, sorry. Write then first write the form of the and this and the set, and it contains x1, x2, 1, such that sorry, and it consists this and the vectors such that x1, x2 real numbers. It's okay. That's one. This set, our aim is to show that and check that V is a subspace or not. This set. It's okay. So and this one is non-empty or not, non-empty. It's okay. So because look at this one, 0, 0, 1, 0, 0. This and this one is in V. Yes, because first one it is not important. Second one it is not important, but third one should be 1. Yes. Any real number, but this one should be 1. It's okay. So and this vector in V because and this vector is in this form. It's okay. So V is not empty set. V is not empty set. It's okay, empty set. So second condition. Take the two vector and the design is R cube and the design is V. It's okay, V. So and take the two element here. It's okay, X and Y. Our aim is to show that X plus Y here or here. It's okay. So and check that and x plus y is the element of V or not. And take the two element in V, it's okay, x. So in V and means and our vector in this form, it's okay, this form. So x is x1, x2, 1. And another one, y sub 1, y sub 2, not y sub 3, and the third one should be 1. In V. Our aim is to show that x plus y in V or not. It's okay? Check that this one. So, and they compute x plus y. X plus y. X is x1, x2, 1, and the plus y, y sub 1, y sub 2, 1 is equal, yes, the sum of two vector, sum of the all components and the corresponding components, x1, y sub 1, x2, y sub 2, 1 plus 1 is equal to. So this one is, third one is, yes, 2. This one is in V or not? Not V, because first component, it is not important. Second one, not important, but third one should be 1 here. It's okay? 1. But, and the third component, not 1, because, and since 2 is not 1. It's okay, the third component. So, and the V, not is closed under the addition. So it is enough to say that, so, and the V is not a subspace of R cube. It's okay? The previous example is a subspace, but this one not subspace. Or both of them subset, but and one of them space, one of them not space. It's okay? So you don't have to check the third one. It's okay. It is enough to say that V is not subspace, and you have to check. You don't have to check that X in V and R any real number, R times X in V or not. It's okay. You don't have to check the last one. It's okay. It is enough to see that, and V is not subspace because not satisfy the and the second condition. It's okay. Any question? No. And also here, the easy way to see that this one is not subspace. This one is the first method. This okay? And the next method, and to see that, and this one is not space. It is easy way. And look at the fact. What is the fact? We know that under this fact. Which one? This one. If V is a, look at this one. V is a subspace, 0 should be in V. It's okay. This one it is important. This one is important. If V is a subspace. Let's come back here. If I think it will be better, and the second method, first of all, and our aim is to show that non-zero, non-empty. And so we know that if V is a subspace, 0 here should be here. But look at the here, it's okay, this one, and this 0, and 0, 0 means 0 vector 0, 0, 0. 0 is not in V because what is the reason? First component x3 is 0 is not 1. It's okay? But we know that this fact, V is a subspace, 0 should be in V, but 0 not in V, so means, so V is not subspace. It's okay. This one, it is enough to say that V is not subspace. It's okay. But 0 is in V, and we don't know and when this one is a subspace or not. But 0 is not in V, so not subspace. It's okay. Any question? So I think it will be better, and if in the first one for every subset, not empty set. I think choose the one, at least our aim is to catch the one and the vector here. I think it will be better, and choose a special vector 0. 0 is in V, and so V is not empty set. But we have two cases. If 0 is not V, and we can the result V is not subspace. It's okay. If 0 in V, and the first one is satisfied. It's okay. I think in this and the first step, and our aim is to show that and V is not empty set. Look at the spatial vector. I think it will better 0. Because not in V, and so we obtain not subspace. It's okay at the beginning. Any question? No, okay. Yes. Another example here. It's okay. And let A and n by n matrix is okay here. Consider a linear system, AX is 0, homogeneous system. It's okay. So here we claim that look at the all solutions of this system and construct a set V. If V contains, and the V is a set, and this set contains all solution of this system, and we claim that these, we know that, and this one is a subset of Rn, because our space Rn, because what is the reason? And the A is n by n matrix, n by n matrix. So, and this one is homogeneous system. So, and we obtain and the number of unknown n here, and because and the column, the number of columns n. So the variable, the number of variable n. So, and the solution here, and this one is A is n by n. The matrix A should be, of course, n by n. It's okay. No, not n by n. Sorry, X is unknown matrix. Sorry, n by 1. It's okay. N by n. This one should be is n, because and these and the multiplication is defined, not undefined. So this one is a vector. So column, and the number of column is 1. It's okay. So, and this X, and if our set contains all solutions, so and our space is Rn. Rn. It's okay. So, and all solutions in V is a set contains all solutions. So we claim that V is a subspace of Rn. It's okay. Let's prove this one. Take the homogeneous system, AX is 0, and we claim that all solutions of and this system start with this system. A is n by n matrix. Consider this system. We claim that sorry, there's a problem.